Good news, everyone. At least everyone that's using Linux. Although you can use Windows with it too. SR-IOV is here on basically everything from Intel. Almost, sort of, kind of, pretty much. This is a portent of things to come. SR-IOV, finally entering the mainstream. What is SR-IOV? It stands for Single Root I/O Virtualization, but basically it just means that you have a single piece of hardware and there's a way to share that single piece of hardware among several virtual machines. Why do you want to share a single piece of hardware among virtual machines? Well, because you can do multiple way different things with a single piece of hardware without having to reboot or change your operating system. You can run the cool Windows stuff and the cool Linux stuff on a single piece of hardware at the same time. It also has lower overhead than the para-virtualization. Think a network card. If you run a virtual machine and it needs networking, all virtual machines need networking, then you can emulate a network card in software, which has a lot of overhead and is not optimal for a lot of reasons. Or your network card can have functions that allow it to be passed through to a virtual machine like you would pass through physical hardware. Well, the NIC in the Minis Forum MS01, the Intel NIC, the 10 gig SFP+, it has SR-IOV enabled. And so you can do exactly that with networking. But also Intel on their iGPUs, it's not officially supported, but you can enable it anyway. And the Intel iGPU, not a lot of horsepower, at least not today in 13th, 12th, and 14th generation Intel iGPU. But maybe someday we will see a NUC that has some reasonable onboard graphics horsepower. Actually, that's kind of a hint of things to come. We also have the A770, a consumer class graphics card that is in the superposition of both having and not supporting single root I/O virtualization, meaning that an ARC A770 can theoretically support multiple virtual machines at the same time, kind of a promised land, a holy grail. And then at the low end of the enterprise, or not really, sort of kind of, there is the Flex 140 and Flex 170. I just recently did a video on those. It's basically the same hardware as an A770 ARC GPU, a little different. It's close though. And that supports a lot of virtual functions through SR-IOV, and actually non-SR-IOV technologies that are specific to VMware and other virtualization platforms that make even better and more efficient use of that. But that one physical piece of hardware can be shared among a bunch of virtual machines. And it actually does accelerate things and makes it go better. In fact, if you use a remote desktop machine, or sometimes it's called virtual desktops in the enterprise, that has hardware acceleration, and then they ask you to go back to one that doesn't have one, you'll be very upset. Because once you've used it and you experience how awesome it is, you won't want to go back. So this video is to walk you through setting up SR-IOV, not on your Flex 140 or Flex 170, but on your Intel iGPU, which is not officially supported. And maybe some other hardware in the not too distant future. I'm waiting on kernel 6.8. Some things are supposed to align in terms of firmware and driver functionality and the magical promised land of kernel 6.8. We're not there yet, but we are going to take a look at kernel 6.5 on Proxmox 8.1. For this video, I'm using the Minis Forum MS01. I actually have it sitting on a desk. This is just the case for it. I don't have more than one, so it's running in the background here. But this would apply just as easily to any 12th, 13th, or 14th generation system. Remember ASRock's Desk Meet? This is a perfectly reasonable home server solution as well. It's not like the Minis Forum MS01. It doesn't have built-in 10 gig, and it's a little tricky to add it. You can do the M.2 cheat codes. Did a video on that where you can add peripherals via the M.2. This is meant to be just a workhorse business machine, but it's inexpensive, and it's very powerful. It's LGA, full-fat LGA 1700, so you can run a 65-watt processor in here. Single discrete double slot GPU. This would be good for like the machine learning stuff though. Like if you wanted to run the RTX 4000 in a machine like this, oh yeah, that'd work out really well. A little overkill, but like this will do SR-IOV as well. Let's get to the how-to on the forum. All right, first things first. Before you do anything, go into your hardware and you got to make sure that SR-IOV is enabled in the BIOS. You can also make sure that VTD is enabled. You can start virtual machines. I'm assuming that you don't need a tutorial on how to install Proxmox. There's a tutorial for that on the forum that we've done ages ago. Tons of people have done Proxmox installation tutorials. You want to get that set up on your Intel machine that you're going to run this on. far as I know, nothing like this is supported on AMD except for Fire Pro, like ancient Fire Pro graphics cards. There are some Instinct cards you can get this working on, but you have to go download drivers that were only ever released to Amazon. And you'll probably need vendor reset because the cards don't reset properly. I've emailed them. They don't. I don't know that it's really on AMD's radar to worry about such things. But you want to get virtualization set up and running and LSPCI and make sure that you can see your Iris Xe graphics. If you already see more than one Iris Xe graphics, congratulations. Somehow you've teleported into the future where this is just something that works out of the box. It's probably not going to be like that, though. All right, the second thing to understand is that there is this Git repository called the i915 backports on GitHub. This is the source where Intel is doing a lot of their work. Now, on this repository, don't make trouble here because Intel is not wanting to be bothered with these off-label use cases, and they don't have a huge number of people working on this. And the fact that SR-IOV works as well as it does is a little bit of a miracle because the business people inside of Intel seem to have different ideas than the engineering people. And so you can see this incredible passive-aggressive war being fought between leadership not understanding what this functionality is all about and the engineers understanding it and getting it and trying to get this out there so that people see how awesome they're doing. And Intel really is doing awesome with SR-IOV, and especially when we talk about Flex 170 and Flex 140. Ponte Vecchio, I'm not sure about. Got to get my hands on Ponte Vecchio. I borrowed remote access to a Ponte Vecchio system for a little while, and the inferencing performance seemed like it was off the chart. But other performance was not as impressive. But that could just be me. That could just be one API not coming together. But SR-IOV and what Intel is doing here, their whole driver universe for Xe graphics and ARC and Flex 170 looks like they're bringing that all under one repository, under one house, which is great from an architectural standpoint because you don't get into weird situations the way that we see with other companies where the left hand has no idea what the right hand is doing and the left and the right hand assume that everything that needs to happen has happened when in fact nothing that needs to happen actually happens, which is frustrating. Anyway, GitHub, the driver, everything going on with GitHub. This is a great repository. It's a great resource. You should look at the commits and the diffs. There's really not a lot going on in terms of pull requests. There is actually one pull request that fixes some null pointers that hasn't been merged in. And the reason it hasn't been merged in is because it fixes null pointer problems with the iGPU on like Haswell generation. I think anything older than 12th gen is going to be problematic going forward, looking at kernel 6.8 and the driver architecture, especially for these off-label uses. So maybe keep that in mind if you're thinking about this for older stuff. But the null pointers is a thing that I experienced on 12th gen that those patches can take care of when you're using SR-IOV. Now, SR-IOV, like I say, on the iGPU is not officially supported, but if you download this repository and you check out backport/main, you can actually compile this on kernel 6.5. If you're on like Proxmox 8.0, it's got an older 6.2 kernel, it's not even going to compile cleanly. Like it's a little bit of a problem. But the Intel engineers really are putting a lot of work into supporting kernel 6.5. And because they're putting a lot of work into supporting kernel 6.5 on their commercial products, it spills over into the iGPU stuff, which is great for us. And also, technically, also the A770, but I haven't shown you that yet. Well, actually, somebody in China beat me to that, but it's a story for another day. So there's a lot of good stuff in this repository. The problem is that some of the good stuff for iGPU is not allowed to exist in this repository directly or indirectly because of the infighting and everything there. One of the best GitHub repositories on GitHub for the iGPU is from Strong Time Zone. Strong Bad's lesser known cousin, Strong TZ. So check out that Git repository and those kernel updates. And this is specifically for Proxmox. These are Proxmox users that are already using it, and they're doing the Lord's work in terms of dotting the I's and crossing the T's and really getting this up and running with SR-IOV. Now, no one is actually going to use an iGPU for SR-IOV to support actual end users. Like, it's too unstable. You get code 43. You get like this system's stable for like 10 hours and then it reboots and other bad things happen. But for running your home Proxmox server or being able to run Docker containers or being able to run Ubuntu, yeah, it's great. It works fine. So in the how-to that I put together on the level 1 forum, it's basically, okay, start with the i9-15 backports, the official Intel repository. Here are the steps that you go through on the forum to get it up and running. But you should be aware that that's not necessarily going to solve your problem, and it's not meant to when you're using it with an iGPU on the Minis Forum MS01 or your desk meet or whatever it is you're trying to get running on your iGPU. And not every system supports SR-IOV. Like, you're not even going to have the BIOS option to enable it necessarily. So strong time zone or strong TZ is managing that chaos for us, and that is also a pretty good starting point. Now, when you do clone this and you do use it, it's still a little bit of an uphill battle. You have to know a little bit about software development, like Intel i9-15 backports. At the time that I'm doing this, there's a bug in their makefile.backports, where they're using tabs instead of spaces when it's doing some compatibility checks. I just comment out those lines. That's in the how-to on the level 1 forum. And then it will build a DKMS module that will let you test it. Firmware is also an issue. Proxmox doesn't include the i9-15 firmware version that you need, the GUC, for this. And if you're doing off-label stuff with the A770 or anything like that, you also need firmware that's not even necessarily going to be in the Linux firmware repository. But the drivers look for those versions. So I ended up not only having to download a firmware version from the Linux kernel website, but also having to create a symlink for the specific firmware version it was looking for. Now, if you look in the git commit history for that firmware file version, it actually was the specific version that it was looking for, and even a newer version, it was like .13 to .20, and .20 was from February of 2024, .13 was from like October of 2023, and the driver was looking for that version of the firmware. But you'll have to pull that, and you'll have to put that in userlib firmware /i9-15. There's also another thing going on here, that is i9-15 is being supplanted by XE. And so there's sort of a branch within a branch in the driver development here that is XE graphics. And technically, these 12, 13, 14th gen, they want to refer to them as XE graphics, even though they're closer to UHD 770 than they are what we see in like the A770 GPU. But there are future embedded notebook, etc. GPUs that really do have ARC graphics and XE graphics. It's something a heck of a lot better than what we have with the embedded graphics on these CPUs. That will be more useful if we can get slice those into SR-IOVs, because when we're talking about the iGPU on a 13th gen, it's like a slice of bread, just the one being subdivided into up to 7 virtual functions. And so that is a paper-thin slice of resources that we're talking about here. It's basically just good for your Plex media server. So understand that, and understand that's what's going on here. If you have the physical room for it, it'd be better to just get another GPU and pass through the whole physical GPU to your virtual machine using Proxmox standard facilities. Once you get the repository set up and everything downloaded, then the next thing that you do is enable the virtual functions. You can, echo 4 or 7 into the SR-IOV num VFS, number of virtual functions. When you do that, and then you run lspci, you'll see a number of virtual functions there that correspond to whatever you told it. So like there, I've enabled 4 virtual functions. The root and the .0 are like the host part of the graphics. Don't add those to your Proxmox configuration. Then you've got 1, 2, 3, and 4. The easiest way to do this is under data center and resource mapping, and then add, and then you should see that in your list. The IOMMU groups column sort of gives you a clue here. I've got 2 Raptor Lake iGPU devices in group 0. We're not going to do anything with those, but we're going to check the other 4 for this mapping device that we create. And this is the most convenient way to deal with PCIe pass-through in this context. Like, this is like how you would do it for real if you had a Flex 170 GPU. With that, you should have something that looks like this in your configuration. And then when you go to a virtual machine and hardware and add and pick PCIe device, you have this radio button map device, and you can pick whatever you want from map devices. I call this group of GPUs vGPUs, and this will automatically pull one from the pool whenever you have a VM that starts. This is really convenient because you can have a mix of Linux and Windows VMs, even more VMs than you have hardware resources available. And as long as you don't have more than 4 or 7 or whatever on at a given time, Proxmox will automatically manage mapping and unmapping the devices to whatever virtual machine needs it. That's a pretty cool feature. Real world, because this is an iGPU and it's not a lot of resources, all this is really good for is doing experiments and passing through functions to, like, say, Docker to be able to run an experiment with Docker, or, like I say, Plex Media Server, media transcode, media encode. QuickSync has a few other hoops that you have to jump through, usually, but it depends on what you do in the guest operating system. And the guest operating system for this is not necessarily going to support this out of the box. So, like, if you pass this through and you're going to do a fresh installation of, say, Ubuntu that you're going to put Docker on in order to be able to run, Plex or Jellyfin or whatever in a Docker container, you're not necessarily going to get console output on this device, even though you passed it through. It does actually work like that with the Flex 170, but these iGPU devices are basically incomplete, not fully baked support. And so you end up having to use a SPICE GPU or multiple GPUs, and then you set one up, and then you do that on the other side. And that's what I did in the Windows VM here. So if you look at our Windows VM in Device Manager, sometimes when you reboot your Windows VM, the Iris Xe graphics is showing code 43. You can usually get that to go away by directly modifying your QEMU configuration in Proxmox to hide the vendor ID and enable nested virtualization and relaxed Hyper-V stuff. I don't know if it's a driver check or just driver bugs, but that's what I had to do in order to get the Intel Xe drivers to install inside the guest. Whereas on the Flex 170 system, it was painless. It just worked. It's pretty great. Interestingly, Windows Update will pick up the Iris Xe graphics automatically, whereas with the Flex 170, it was a manual install. It also works for you to change the vendor ID. So, like, if you just change the PCIe device ID using your QEMU configuration on the Linux side, you can get a little bit better compatibility. It will work around some of the driver issues, which is a really interesting situation, I think. I am sure that Intel is not testing that use case, so your mileage is going to vary there too, but it works. At the time that I'm shooting this video, driver version 5186 seems to work okay for this use case, and Strong TZ's iGPU i915 repository works a little better than the i915 backports repository using the backports/main branch for what that's worth. If you use the backport/main branch of the i915 official Intel repository, you're likely to encounter null pointer dereferencing, but if you apply that patch from the issue tracker and do a couple other things, you can get the i915 backports thing working, even with the V20 firmware from the Linux kernel website, but most people don't care. Most people just want a home appliance to be able to run Home Assistant and Plex Media Server or Jellyfin or something like that. And the hardware transcoding facilities, QuickSync basically, that is in your iGPU is more than enough for most people to run a home server use case. So that's really one of the widest use cases for this kind of thing. So this is more speaking to the Intel people that would be a little hesitant on the suit and executive side. Most of the people that want this functionality just want to be able to have a single machine that can run Docker and Linux and Windows virtual machines and a couple other things. And the iGPU doesn't have enough horsepower for that to even be a threat or worry. Now, does it make sense for Intel to dump a bunch of engineering resources into supporting that use case? No, because it's not a lot of GPU to begin with. No one should be using this commercially. No one should be tempted to use this commercially. And I assure you, from having to go through the crap in the GitHub repository and having to rely on folks like Strong TZ, no one will rely on it commercially. But if we have a gaming GPU that has 2 or 4 virtual functions that can be used for this kind of use case, then it opens up a whole new world of possibilities, not just for those home lab use cases, but interesting things on Windows. Look at the Windows subsystem for Linux. It's taken off. Like, there's more people using the year of the Linux desktop, Linux under Windows, which is definitely a suboptimal Linux experience, then there are people running natively. Look at NVIDIA. NVIDIA's CUDA stuff runs better under the Windows subsystem for Linux than it does natively on Windows, to the extent that NVIDIA is basically not doing native Windows development anymore. Okay, there's some hardware driver stub stuff that can't not be on Windows, but I'm talking about like the control plane stuff and the automation. It's a very light wrapper to an API that you get on Windows, and there is no Windows GUI. There is no Windows equivalent because it's better and it makes more sense to just run the Windows subsystem for Linux for those facilities. This could be the same with an Intel GPU. This could be the same if you're running PyTorch and passing something through. This is already largely the same for containers. And Intel had a good start with GBTG for this kind of thing. Intel had a great start with this on their, 1230 V3 and V4 Haswell era Xeons to be able to support this kind of a use case. And so in some ways, Intel has regressed a little bit because all of those things did not align as much as Intel's graphics stack aligns now. And so I think everybody really is interested in this kind of functionality for a whole bunch of different reasons. But ultimately, the time for the para-virtualized GPU has long since been upon us and really does need to be a thing. And it is amazing that no one in the industry has managed to get this right in a user-friendly kind of a way. It's all about lock-in and proprietary standards and things that aren't amazing. And to be sure, SR-IOV is not an amazing technology. It actually has a lot of shortcomings, which is why the Flex 170 uses something different optionally with VMware. And the thing that you can do on VMware to get a whole bunch of seats on a single GPU, specifically with the Flex 170, is far superior to what you get with SR-IOV. But SR-IOV is open enough, mostly, and standard enough, mostly, that it's the accessibility that's the draw there. So hopefully you get some mileage out of my tutorial. Check that out on the Level 1. Check that out on the Level 1 forum. Let me know what you're into. Let's improve the tutorial and go from there. But Proxmox officially supporting Flex 140 and Flex 170. And yeah, you actually can get a Flex 140 and a Flex 170 from Dell and Supermicro and everybody like that. Street price, I'm seeing between $1,600 and $2,800 US, give or take, on that Flex 170. A Flex 140 is 2 lesser clocked, lower VRAM GPUs on one card, half height, half length. So it's a little different critter. But Flex 140, Flex 170, it's a real deal. Works really well. Oh, and if you do need to change virtual functions and other configuration stuff, there's a separate thing that you need to know on the Level 1 forums. There's you need a CSV file that contains all the parameters that you have to send to the card to change the number of virtual functions and a whole bunch of other stuff. I'm probably going to post that on the forum. You can kind of it's there already, but I need to post it publicly. I just need to, if you look at the i9-15 backports driver, you can kind of suss out how to control all that. But it's really interesting because it's not actually posted anywhere. So I'll probably post that on the Level 1 forum too, because you can configure, it gives you a rough estimate. Okay, if you tell the Flex 170 GPU this, you'll get this many virtual functions, and you can roughly count on it doing, 1 4K stream, or 2 1080p streams, or 4 720p streams for remote desktop or virtual desktops or GPU acceleration or whatever it is that you're working on. I have not produced a similar mapping for the Intel iGPU, but that Intel iGPU really struggled. I've got 7 virtual functions. You're really going to struggle to get more than 1 or 2 streams of 4K going at once. There's not a lot of GPU horsepower there. And splitting it up that many times adds a lot of overhead. So I'm Wendell, this Level 1. I'm signing out. You can find me in the Level 1 forums. Woo! Level 1 Linux. All right. I'll see you later.